Okay. All right. So I've got a cozy little group this morning. I don't know what time of day it is for the rest of you. So I just had a placeholder title here. I did want to do something better, but I decided to work on the content instead of spend more time on the title. So it does cover data presentation and insights. It's sort of looking at where you can go to next with your studies and with your developing skill set, and I guess looking into where we also do some teaching at Curtin in predictive analytics. Yeah. So we'll go through some, it's a bit of a revision because it's been a little while since you might have met me during the Module 3, I think, Module 3 or IoT3 Module 4 with looking at data in the cloud. So there, I'll go through types of data, a little bit about presentation options, a bit about dashboards because that's where a lot of people are working with their data. Talk about predictive analytics and where you go after just presenting the data to be getting some insights and then turning insight into action. So a little bit of a reflection. So setting up the things in the Internet of Things, and we've helped them to communicate. So we've connected them up and have those that data going through our network. And then we work to be able to provide storage and bring that data to rest, so it's not the instant data that's coming off as a stream anymore. We're wanting to be able to do some analysis on it. So it might be the orientation, movement, temperature, light sensor data that's coming through. It could be videos and images. It could be locational data, which I think Dave McMeekin went through in the previous presentations. Or it could be just taking account of some event that's happening and you're getting an idea of how many times or how regular that event is. But there's different types of data, usually numeric, but more so video and images coming through now too. So initially it's coming through in a raw state. We need to be able to take that in. The sensor themselves, they don't know where they are in the world, so that information is added as it's sent through the network. And once we have all that information, there's a lot of it that we can strip off to be able to reduce the amount of data because we have a lot of excess information coming and it compounds. So if we're getting 10 readings a second, then multiplying that by the number of minutes you're taking it, by the number of hours, by the number of days, and how big each of those bits of data is, you'll end up having a large amount of data coming through. So we want to be going through, making sure we can identify the data, where it's coming from, then be able to strip it back to the data that we actually need, identify it, and maybe have to do some sampling to get it to align to the same timestamps as well. There might be some other data that we want to combine with it. So a typical one is weather data, so external weather, just to see how that impacts on the other sensors we're looking at. And then if there are any problems with our data, we can go through and use statistical tools just to see any outliers, to see if there is anything that's gone wrong, like a blip on a sensor that gives us data that we don't really want to have in our overall analysis. So going through, we take that raw data, over here, take that raw data and do some data cleaning. Get it to be technically correct and consistent, and then we can start to trust it. Okay? It has to be at that trustworthy state before we do any analysis, and definitely any machine learning on it, because we don't want to have spurious data that will mislead our results. But all of this work should be done somewhat manually to start with, and then once you're aware of what things to expect, you can automate that and make it very systematic and document your process so that you can scale it to lots of sensors or a long period of time without having to intervene too much in the process. Okay, so from the case study that was part of the module, Some basic data cleaning might be to go through and find any occurrences of, say, a 0 for the temperature, because in Perth we don't get 0 degrees as a temperature, and 85 degrees would also be impossible. But looking through the data, the intern that did this work, Jack, went through and he saw that there were these data points in there, and they were obviously incorrect data. So replacing each of those with not a number to indicate that there is a problem there, and then on the next line dropping all of those not a numbers if there is any incorrect data on that that data point, to delete it. And so you would go through and check to see if that's the appropriate response depending on what you're working on. Okay, and it was taking the date and converting it to the format that we want as well. So that's the data cleaning for that case study. And then going through and combining some data, so taking the data from the sensor, Thursday the 7th, reading that in, but also taking in some data from the Bureau of Meteorology. So that in Perth, the weather data is collected by the Bureau of Meteorology, and so you have those two data sets that you can then align. So going through, making sure that they're on the same time frame, the same start and end date, and having that data lined up so then they could be plotted. So plotting the two data sets onto the same axes, and you get these sorts of results. So we're doing this with any sensors that we have, and doing this as a somewhat manual exploration to start with until you are sure that you've seen most of the issues that might come up and how you want to adjust things. So we've got the Bureau of Meteorology data in blue here, and the sensor for the materials for the temperature is out in the sun, and you can see that there's a big change in big difference in the values there, which is repeated each day, but there was a little blip here, which would be a problem with the sensor at that time. Okay. So depending on what data you have, what type of data, and what you're trying to show or extract from the data, you could have different types of charts, and the dashboards and plotting tools that are available will give many of these different types of charts. So if you're wanting to compare the values in two lots of data, you might have columns or line charts going over time, or just in terms of counts of items, you might have column charts and tables that you work through. Looking at a relationship between two variables, maybe a scatter chart or a bubble chart, so you could have colours to indicate different values in there, or the size of the circles in a bubble chart to give you more information. Also things like the distribution of values, scatter charts or histograms can help with that. And then looking at the composition, so overall data, how does it break down into different components? So if you were trying to think of any of the projects that I've heard people talk about, if you're tracking different movements in a wireless network, you might be able to have a different value for a student ID as for a staff ID. So having that sort of composition in the graphs or plots that you put out helps you to extract that information and see it more clearly. So it's very easy in a dashboard to just pick a line chart or a gauge or a pie chart, but you have to be matching it to the type of data and what you want to be able to see and identify in that data. So this chart is a really good one if you're ever thinking about maybe there's another chart that I can use rather than the default line chart that comes up, because a lot of the time a line chart's actually the wrong one. I've seen a really good one, this circular area chart. When we did the course recently from Amazon Web Services, they were doing a comparison along multiple characteristics of the different types of instances that you could run in AWS. So how many nodes it had, how much memory, all the different things about how fast it was, And it was a really good way to compare two different instances. And I was very impressed because I hadn't seen that use before. So with that, when you go into the dashboard services, this is really what you're met with. You've got all of these different options to connect to and log your data, and also to display the data. So you start up with all of your devices, register them with that cloud service. I'll give a few examples shortly. Just select these display options. What do you put on your dashboard? And if you want to have any alarms or notifications, if we go past a different threshold value, you might want to send an email to someone or a text. And then you could also be sending information from the device to the dashboard, but the dashboard could also be controlling the device depending on the data that's coming in. So a few options: ThingSpeak, Freeboard, if this then that, IFTTT, ThingsBoard, and Initial State. I'm not sure how new it is, but it's they've got some very good videos and a very good option there with Initial State as well. Okay, so just a few options. So ThingSpeak, some of the graphs that you could put up with that. So just watching the correlation there. So you do have perhaps them in different charts, but you might find that it's useful to overlay on the same chart when you've got the same variable. So this is temperature and humidity, which of course you wouldn't overlay, but working through if you had multiple sensors doing temperature in different places, you might overlay them. Freeboard is another good option. So looking at how you can connect to or register the sensor that you're looking at, give the type of sensor, so just a pull down to get the type of sensor. So that's how easy it is to choose the type of plot or widget that you're putting on. So it is important to think about it, or maybe play with a few different ones to see how they work for you. But a temperature gauge going up with a fairly readable format there, and if you have a lot of them, you'd be able to perhaps color code them as well to say when they're getting into a dangerous value, so that would make it much easier to read. And that's one of the examples for ThingsBoard. You can say that they've got different gauges, and if you're looking at bus fuel, that's a really useful gauge because we're all used to looking at gauges like that on our vehicles ourselves and the speed of the different buses. So being able to compare them and see where they are on a map, so putting a map into there, and it gives them a good way to oversee what's happening with those buses in real time and what sort of layover there is, and seems to be some interesting patterns in that data as well. So again, multiple ways of seeing the same data, overlaying the data for multiple sensors, for multiple entities that you're watching to really help make those comparisons and not have too many things on your dashboard as well, because it has to be clear and obvious so you can see exactly what you're searching for. Okay. With them, so working out what sort of information you're taking from your sensor and what sort of responses you can give to it as well. So there's a lot of flexibility in there, and those are the things to be working through and knowing what your options are and all the activities that you want to do. So it could be quite an iterative thing, but also thinking that we've got to put security into all of these exchanges that we open up. Initial state, so this is one that I've been watching lately. So they have quite a lovely system there, very flexible. You set up your desktop for whether it's on a computer, or you can copy that and rearrange it so that it can work on a mobile as well. And people are even more working on their mobile phones rather than on a full desktop these days. So that's something to really consider. And then overlaying on maps, black background, white background, that inverts as well. But also having interaction on there so that when you see something, you can drill down, go to another page of the dashboard to do extra work, so you don't have to have everything on one page. So really nice set up there. Again, another skin on the initial state dashboard, and in this case they're taking in data from dark sky weather data. So that's all around the world. You can get weather data from there with their API, and you can do 1,000 calls, requests from that a day without having to have to pay for it. And then you can really add some more information into your dashboard, where in this case they've got the temperature in the office and the temperature outside of the office, looking at correlations, how happy it is, or how comfortable an environment that they're in, and I guess letting them know what is happening in the outside world when they're at work. Again, a really nice looking dashboard there. Okay, so we've got the dashboards, and that's one way to get the data streaming in and connect up with our sensors, but we also might need to do a bit more storage, and we talked a little bit in the cloud section of the course. We looked at the running instances and doing processing in the cloud, but it's also important to realize that you can be doing a lot of storage in the cloud, and there's different options that say for Amazon Web Service, which we'll go to the next one. So with Amazon, the S3 storage is for objects, so you can put files in there, but they also have a database option there where you can be, they've got a relational database, and you can be putting your data in there via SQL. So there's a few things. There's archival data that they make available, or an option there, so the Glacier. So there's a lot of different storage options, and realizing or go through and work out how much data you expect to be storing, because the free tier, so you can store 5 gigabytes without having to pay anything, and they do keep a track on your read requests and your put requests, so how many queries you make and how much data you put up. So that's something to track, because it can blow out, but at the same time there is you can't really do better yourself than the 11 nines of data durability, so that is the uptime, and they won't lose your data unless the whole company goes down. But Amazon is a survivor amongst cloud companies, so they're pretty likely to stay around. Okay, so that's for maybe more short-term data, but if you were wanting to bring a lot of data together, you might use their data lake project product, and that's available. A similar things available through other providers, and organisations are making their own data lakes as well. So bringing all of their data together, keeping it central, keeping it secure, sort of that pendulum switching to centralising again. But it means you can do all that, the analytics, have all of that information together, not having to worry about transferring data, and then have all of your data management looked after centrally as well. So it's another new term that they've brought in recently. Okay, so even though for a price you can have unlimited data storage through Amazon and other providers, you do have to be aware that you're going to pay for it, and there will be a bill at the end of each month. So it's important to make sure that you only store the things that you need to store, and store it at the resolution that you need it to be stored at. So you don't, if you've got very high resolution images, but you don't need them to be that high resolution, or you've got different intermediate steps of your data where you're going from the raw data to the data that you can put into a machine learning classifier, you don't need to store all the intermediate forms, because you can recreate that just by running your programs again. So there's a lot of places where you could reduce the amount of data that you have to store, so it's something to consider. So yes, if you've got big data, one way to make it less of a problem is to make it less big by deleting some of it. So there's an option. Right, so we've got our data, we've got it all available in a good format, and what we might be able to do, what we might be thinking is saying, okay, I can understand my data in terms of what's happened in the past. Descriptive analytics, being able to graph what's going on, see some level of what's happened historically. But if we want to be able to do some sort of predictions and see from that data what can we say about what's happening in the future, we need to work in predictive analytics. So we might be able to say, how do we look at the patterns in the behaviour of the data so far? What sort of patterns indicate that there's something going wrong or something going right? That could be in the stock market, when you should buy and when you should sell. Looking at a hard disk or a fan that's about to fail. There's ways that we can perhaps identify signs that that's about to happen and be able to take action beforehand. So machine learning can help us with this. Okay. So instead of coding everything up, which we usually do when we're programming, instead of doing all the coding ourselves and saying what are the steps that will have to happen to go from what we start with to process our data and get our output, with machine learning we can use programs that learn themselves and respond to the different inputs and then can give you an output that you didn't expect, which is never what we want in normal programming. We want the outputs we expect. So in these machine learning tools, we can have a model of what the system is, what our data is doing, and then be able to classify the outputs, and the overall result will be a model that can say for a particular set of inputs, it knows what the output is even though it hasn't seen that combination of data before. Okay, so there's things, algorithms for clustering and supervised classification, rule systems, so ways that you can take a lot of data and have it, have the machine learning tool give you a set of rules, like a flowchart that says how to make the decisions to classify that data. And we've got the neural networks, which are a bit more of a black box, but still get some very interesting and amazing results. So even though they're not transparent, they're very effective, so people are using them a lot. So what we can go through in this case is, instead of saying how do we put all the information together to work out what the answer is, we say we've got all these answers, we've got all this information, and we want to get to this end goal, and let machine learning work out what has to happen in the middle. So far less of us having to understand the full problem, and far less of it being that you, in understanding the problem, you're putting your theories there. You have to have a model of the concept that's being that you're observing, whereas with machine learning it can do it without any preconceptions. Helps us break away from that. So it might be used for predictive maintenance or for optimizing logistics. So in one study, there was a 15% reduction in fuel costs when they monitored and coached the drivers to drive differently, like not speeding, I guess, and not braking hard and speeding up quickly. So in that monitoring of the driver habits, they've found that they could get a 15% reduction in fuel costs. Being able to, when you've got, I think most of us would have used a voice recognition call center when you can't get it to understand what you're saying. And so they could overlay on that something that recognizes the emotion in your voice. And if you're getting angry and annoyed with it, then send you through to a real person. So that could be a way to reduce frustration of customers. Looking at photo tagging, I think we've all seen that in Facebook and similar. Looking at image analysis, so detecting things in scans from microscopes, or working out whether we can help people to go through a checkout more quickly and easily using object detection. So there's lots of applications in different places. And what we find, we've got the pink area here, so that's the historical, the more common analysis that we've been doing for many years. And then at the blue area, we're using machine learning and having actual live monitoring and actions based on what's happening at the time, and the alerts going out to change the system that we're working on. So you've got a feedback system that's happening in these big data architectures. So going through the workflow, it's still a similar problem to any data analysis, but so we start with identifying the problem we're looking at. So we may have an overall data set, but I would focus on specific problems each time. So how many people are using a park? Can you get that information by having a sniffer to check for Bluetooth or wireless signals, and then be able to extrapolate from that. Looking at the data size and type, so what data are we collecting and how much of it? Then curating that data, exploring it just to make sure that it is clean, there's no weird values that we didn't expect. And then identifying, training and testing a model. And what I'm observing is that it seems common to not just pick one model. It might be 4 or 5 different approaches that get taken, and then whichever one performs best, you pick that one. So it's an interesting approach, not as scientific as you might expect, but multiple models being used is the new way to do it. I think one of our companies here in Perth says they throw 20 models at a problem and work from there. So it's really about having the processing power to do that. So once they've got a model they're happy with, they deploy it, and then they do some visualization on the outputs. Okay. So again, they've got this flow through of the different things that are going on, but there's different people involved. So I know that the people studying these units with us are from different backgrounds, and you can see where you might fit in this this overall workflow in terms of data engineers, data scientists, production engineers, the people that actually put the changes through to the live system in the field. So there's a few different roles in there. And the machine learning, this is just to highlight that although it's very topical, it is a tiny little bit of what's all of the work that goes on to monitor and keep track of what's happening with a system. So, but all of this has to be good and well curated for the machine learning to be effective. Okay, so there's a bunch of different tools that are out there. These are just a few of them. So TensorFlow is very popular. That's developed by Google. So you do have scaling available in that. Scikit-learn is available as a package with Python, and so that's on a desktop version that you can use. Keras is, I know the Curtin Institute of Computation data scientists use Keras a lot. So they're developing their neural networks, and then Amazon and Microsoft have their different options as well. So it can be, if you've got your data sitting in, say, Amazon S3 storage, then it would make sense to perhaps use their tools so that you're not having to move the data around. You've got the processing where the data is, and that's a lot less transferring of data. Okay, so the challenges with working with IoT, we've got lots of data coming through. We need to be able to work with that, and that's the volume, velocity, veracity, and variety. Lots of B's in there to challenge us. And ways that we can address the challenge is by automating our cleaning process, being able to, where we can, reduce the amount of data, so reduce the resolution and the duplicates of data. Using dashboards to display data and set alarms, so those IoT dashboards, like Thingsboard, really good options. And then once we know that we've got our data well looked after and well defined, we can then start doing things like apply machine learning to be able to extract some insights from that. And then really with that, you can't just go blindly into it. It really is important to focus on a metric which might be reducing the amount of fuel used with the driver's example from earlier. So focus on the amount of fuel that's being used, and then just see how they could apply models to reveal possible solutions to what's going on. And in that case, they probably found that some drivers use less fuel than others. What was it that was a difference between those drivers? And that would have become apparent from their analysis. So that's, I guess, it. I just wanted to mention that we do have a predictive analytics course, master's course at Curtin. I'm the course coordinator for that. So the Master of Predictive Analytics, we have a grad dip and a grad cert option there. Grad cert is 4 units in first year. Grad diploma is another 4, so 8 total in a year. And then it goes into 3 different streams, so resource operations, finance and investment analytics, and we're going to have health informatics and an AI and data analytics stream go into those second years with lots of different options to take on there. So that might be something of interest. It isn't, we only have it on campus, so it's not an online option there, but it is something that we may have some of those subjects that would be available. And I think Ian's got some engineering qualifications that people can take up that might include some machine learning and AI and predictive analytics, if that's of interest. Okay.
That is true. And also, Val and I could probably work out some way of arranging credit for the MicroMasters going into the Predictive Analytics Masters, as long as you meet the normal prerequisites, of course. So this could actually count towards a graduate diploma or Masters in Predictive Analytics, if that was something you wanted to do.
Okay.
Back to you, Val.
Oh, well, I'm finished, so I don't know.
You're finished? Okay.
Yep.
Thank you, Valerie. Do we have questions for Valerie? I'm going to show a few of the little things that I play with. So while we're waiting for questions, me back as the presenter, I hope. Yeah. Okay. It's not that one. It's this one. Okay. Can you see that mainly white web page?
Yes.
There's a few other ones that I particularly like with the dashboards. This is probably the most Valerie mentioned it, but didn't actually show too much on.
That's very pretty.
Yeah, I do like this one. It's really, really simple to use. It's mostly free, so it works well. One that we used with rather good success, and I don't have a good sample of it up here, but Losant was something that was very, very easy to use. Again, free, fairly low bandwidth requirements, because we actually ran this one when we were in Myanmar. We had our little project that the course we ran over there, using Losant directly to measure the automatic pot watering. It allowed us to send a SMS message out when the plant was watered, and all kinds of nice little features. So that's another one that's worth having a look at. And if you're doing anything really commercial, large, has to be reliable, and cost isn't as big a factor, Cisco have their own one as well. And again, it doesn't give a very good examples of it. But this is what you would use in a real production run. Connect, as in same as the movement scanner by Microsoft. But it wouldn't be cheap. I don't know exactly how much it is, but it would be very reliable and probably worth considering. With the machine learning side of things,
with the Cisco one, I've seen the interface for that, and it's quite amazing, because they do have so much on the networking side. That's the Connect is really, really amazing in terms of how flexible and easy it is to work with. It has a lot of power.
Yeah, and being with Cisco, like most of the large, very commercial companies, you would have things like security built into it. There's the AI tools. The infrastructure behind it would be pretty much bulletproof. So in mission critical areas that would actually help a lot. But I think, knowing Cisco, it would be really, really expensive. Now, you were talking about the AI platforms. Have you played with Valerie?
Yeah, I used that when I was working on my PhD. So I was using classifiers, so the C4.5 classifier, and working in Java. I haven't used it for real time, so it didn't like rate highly in looking at what are the top tools, but it's definitely one to work with in sense that it's accessible. It has the graphical interface that you can work with, and then you can code things up to actually just call them as the Java classes as well. And of course, free and open source is a big plus.
That's what I was thinking. Open source package, it might be worth considering. Anyway, that was just the ones I'm on show that I've had a little play with, except I haven't played with Weka, of course. I'll stop sharing if I can find where my buttons are. Okay. Do we have any questions there, Savash?
Well, you're the host, but I can't see any questions coming in through the chat.
Make you. You've got to do the last one.
Hello, professors. Can you hear me?
We can, yes.
Go ahead.
This is Carlos from Costa Rica. Hello to everybody. I have two questions. Number one, I have never set up a web service, and I have never obviously set up a presentation. If I want to use a service like the ones you presented, like Thingsboard, do I need to have the data stored in their site, or can I have it stored in Amazon Web Services and then make a connection to the presentation site? How does that work?
That's for you, Val.
It can be a combination of it. So you do register your sensors. So if you've got real-time sensor data coming in, you register it with that dashboard. And so that is something to think about as to trust levels and that sort of thing. There is a full IoT setup in Amazon that you can also go through this whole process of they've got an end-to-end solution amongst their 60 plus products that they have in their suite. So I know I've got from 2017 a white paper called Deploy an End-to-End IoT Application in Amazon Web Services. So that's in terms of registering your sensors, storing the data, having that whole workflow, and having the analytics as well. So depending on what things like a dashboard and having alerts go through in real time, one of these others like Thingsboard would probably be really good, but I would probably think if you're going to actually be applying machine learning and wanting to store the data, then keeping it on Amazon or an equivalent, so as you would have the same sorts of things, would be good. I know that you can with Amazon with the S3 data storage, you can just use HTTP queries to be able to store data and retrieve data as well. So there's a way to use good encode into your scripts to send and receive data from Amazon. You could put that into a dashboard as well.
Thank you very much, Professor. And I think I have another question, but it just blanked in my mind. So give me 1 second, and I'll try to remember what was it. Okay.
No problem.
Fine.
Anyone else?
Now I remember.
Okay, go ahead.
The thing is, if by any chance I need to provide part of this presentation to the users of the devices, because Amazon Web Services offer any kind of personalized website for the users. The thing is, in my project, that is the Smart Shower, one of the ideas is to provide the user with the capability of monitor what is their own consumption of water and electricity. And of course, they would need a personalized view of the data they are producing. And I don't know if Amazon Web Services offers this kind of service.
You can certainly go full depth and be able to set up an instance, so your own Linux server through Amazon Web Services, and host a website on there and then put the data into a website. If it's fairly static and it's just calling things, so embedded, some of the widgets that I saw on, I'm trying to think which it was on, you could just have embedded code, so it was just an embed tag that you put in, and then that widget would appear on your page. So if you were using Amazon Web Services and having static pages there, and you can do that just by storing the static pages on S3 on one of their data storage products. Now, I haven't tried it, but you can actually get an IP address and a domain onto that, and have access rules on it, and use a static web page, which might be enough. Okay, rather than having to have an instance that's running all the time and having its own security issues, you could have a static page sitting there. So there's a few different ways that you could do that. I'm not sure about ThingsBoard in terms of, I know that we could set up all these dashboards can set up separate pages, but it's whether they can exclude people from different pages as well. So I don't know. Ian, have you done anything like that?
Yeah, Lawson can do it, so everyone gets their own dashboard and the data is separate, but that takes a little bit of configuring. So I don't think it'd be a big problem. I tend to be looking at one of the open source ones that you can actually install onto an AWS, so that you spin up a machine for each one of the clients, each installation perhaps. So they have their own VM sitting in AWS.
Yeah, eventually that will cost money.
Well, it would, but this would be on a subscription basis, I'm sure. Either that, or you could set it all up back at your on a or something completely in within the customer's premises.
Okay, that is a good idea. Thank you very much for the suggestion, and I will definitely investigate more about the subject. Thank you very much, professors.
Right.
Okay, we've got 10 minutes left. Do we have any other questions? Oh. All right. Sebastian, want to make any comments on the final reports?
So in general, I'd say as when I see when I send you the feedback through the email, that just might take a little bit of time because we're just going through and marking them at the moment. I do highly recommend, for those of you who got to the prototype stage, which we're, I'd say, probably 80% of the report that I've seen so far, really encourage you to kind of take that further and investigate doing a PCB design of that, because lots of the ideas were good. There were good plans for them, and then taking that one step further and building your PCB so you have something very nice and small, and then think about the casing for it. That's really going to make a big difference if you are thinking about going commercial. Otherwise, no, I would, as Ian said at the beginning, we're very impressed with the quality of the reports.
Okay. I'll mention again, we've set up a Facebook page if anyone wants to keep in touch. So we're done, finished for the course with you guys. We will have the results in as soon as we possibly can. Shouldn't be too much longer. Savash is working night and day on it.
I expect probably by the end of this week. From the ones we received, I think we just have 10 more to mark, and then I'll go through and update the marks on WebEx. edX, sorry.
Well, thank you very much, everyone. Keep in touch via Facebook, and I hope you got something. And maybe we'll see you again.
Thank you, everybody, for your time and your input. It's been fantastic.
Oh, would really appreciate feedback on the edX site, or even email it if you've got things you would like to see changed, improved, deleted, added. This is our first run through the full program, so yeah, we'd really like to know how it went and what we could do better.
It's fun sticking with it and working so hard. That's
Online learning is not easy. It's not the easiest way to do things, quite honestly. It takes a lot of motivation and time. So well done.
Well, my first feedback is credit on the content that's kept us all engaged. So that's why we're here at the end. So well done to all of you who put this together. I've really enjoyed it.
All right. Well, thanks very much, and keep in touch via Facebook if you like. Good luck with your IoT in the future.
Thanks a lot for everything. We're gonna miss
Thanks, everybody. Goodbye.
Ciao.
Bye.